When we look up at the night sky, we see stars shining and sometimes imagine the sounds that might come from outer space. Maybe explosions, whooshing spaceships, or the roar of planets moving around. But the truth is, space is completely silent. Even though space is full of amazing and powerful events, no one could hear them because sound cannot travel there. To understand why, we need to know how sound works and what makes space so different from Earth. Sound is a type of energy made when something vibrates. For example, when you talk, your vocal cords vibrate and push air particles around. These moving particles bump into other nearby air particles, and the vibration keeps passing along like a wave. That wave reaches your ears, and your brain understands it as sound. The same thing happens when a guitar string vibrates, when thunder rolls through the sky, or when a car engine runs. All these sounds reach us through the vibration of air or other materials. Sound can move through different materials such as air, water, and solid objects. For instance, if you put your ear on a railway track, you can hear a train coming before you see it. That's because sound travels faster through metal than through air. Sound waves move differently depending on what they travel through, but they always need some kind of material, something made of particles, to carry them. Space, however, is very different from Earth. The area between planets, stars, and galaxies is called a vacuum. A vacuum is a place where there are almost no particles, no air, no water, no solid materials. Since sound needs particles to vibrate and move, it cannot travel through a vacuum. Without air or any other medium, there's nothing to carry the vibrations from one place to another. If you were floating in space and someone next to you shouted, you wouldn't hear anything, even if they were very close. The sound waves from their mouth would not be able to move through the empty space between you. On Earth, their shout would make air vibrate. But in space, the vibrations would simply stop. Movies and TV shows often show huge explosions in space. Spaceships blowing up with loud bangs or meteorites crashing with roars. While these scenes are exciting, they are not scientifically correct. If a spaceship really exploded in space, you wouldn't hear a sound. You might see a bright flash of light, and if you were close enough, you could feel the force through touch, but your ears would hear nothing. Light can travel through space because it doesn't need particles. It travels as electromagnetic waves. But sound waves are mechanical. They need something to push and pull on, which doesn't exist in a vacuum. You might wonder how astronauts can talk to each other if space is silent. The answer is that they don't rely on sound traveling through space. Instead, their communication systems use radio waves, which are a form of electromagnetic energy, just like light. Radio waves can travel through the vacuum of space. When astronauts speak inside their helmets, their voices are turned into electrical signals. These signals are then sent as radio waves to another astronaut's headset, where the signals are changed back into sound. This allows them to talk even though there is no air around them. So, when you hear astronauts speaking to each other in space videos, you're actually hearing the sound created inside their helmets and sent by radio, not sound moving through space itself. It's also important to note that while outer space is silent, the inside of a spacecraft is not. Inside a space station or spaceship, there is air, just like on Earth. This means sound can travel inside. Astronauts can talk, hear machines running, and even listen to music. The silence only exists outside the spacecraft, in the vast empty space beyond. The silence of space might seem strange or even scary, but it's also part of what makes space so peaceful and mysterious. If we could somehow stand on the moon and take off our helmet, which we couldn't really do and survive, we would not hear anything, not even the sound of our own breathing. The moon has no air to carry sound waves, so even a hammer hitting a rock there would make no noise. You could see the action, but it would happen in complete silence. This silence helps scientists learn more about the universe. For example, instead of using sound waves, astronomers use telescopes to detect light waves, radio waves, and other forms of energy coming from stars and galaxies. These signals travel easily through the vacuum of space and tell us about planets, black holes, and distant galaxies, things we could never hear, but we can see through special instruments. In summary, space is silent because it is a vacuum, a place with almost no particles to carry sound waves. Sound needs something like air, water, or solid matter to move through. On Earth, we are surrounded by air, so we can hear everything around us. But in space, there's nothing for sound to travel through. This means even the loudest explosion or the biggest event in space would make no sound at all. While the idea of complete silence might seem lonely, it's also fascinating. It reminds us how special Earth is, a planet full of air, sound, and life, in contrast to the quiet, empty beauty of space.